Hello friends, welcome back to the channel. Imagine you open Instagram, you tap on a profile, and within milliseconds, the profile appears. No loading, no waiting, almost instant. Now think about this, that profile data already exists inside a database. So why doesn't Instagram simply ask the database every single time? Why do companies place Redis in between? And what exactly happens when the data is not inside Redis? Today we're going to understand one of the most important caching patterns used in real systems, cache aside pattern. And trust me, by the end of this video, you will understand exactly how applications use Redis to reduce database load and serve millions of users faster. Let's begin. The problem. Imagine we have a simple application. A user opens a profile page. The request reaches the backend server. The backend asks the database. The database returns the data. The backend sends the response. Simple. Now another user opens the same profile. Again, the backend asks the database. Again, the database returns the data. And this keeps happening. Hundreds of times. Thousands of times. Maybe even millions of times. Now ask yourself, what is the real problem? The same information is being fetched again and again. The database is repeating the same work. And as traffic grows, the database starts becoming a bottleneck. So engineers asked a simple question. Can we store frequently used data somewhere faster? That is where Redis enters the picture. What is cache aside? Think of Redis as a super fast storage layer, much faster than querying a database. Instead of directly going to the database every time, we first check Redis. And this idea leads us to cache aside. Cache aside is one of the most popular caching patterns used today. The application controls everything. The application decides when to read from cache, when to read from database, and when to update cache. The cache sits beside the database, which is why it is called cache aside. First request. Now let's follow a real request. Imagine a user opens a profile page. The request reaches the backend server. The backend first checks Redis. It asks, do I already have this profile? Suppose Redis doesn't have it. The data is missing. This situation is called a cache miss. The cache was checked, but the data was not found, so now the backend has no choice. It must go to the database. The backend sends a query to the database. The database finds the profile, returns the profile information. The backend receives the data. Now something important happens. Before sending the response, the backend stores a copy of that data inside Redis. Why? Because future requests may ask for the same information. So Redis now contains the profile. After storing it, the backend sends the response to the user, and the request is complete. The first request was slower, because it needed a database query, but now Redis has the data, and that changes everything. Second request, a few seconds later, another request arrives. Again, the backend checks Redis, but this time Redis already contains the data. Redis immediately returns the result. No database query, no disk access, no expensive operation. The response returns almost instantly. This is called a cache hit, and this is exactly what engineers want, because cache hits are fast, very fast. Why this is powerful? Now think about what happened. The first request touched the database. The second request did not. The third request did not. Maybe the next 1,000 requests never touched the database. One database query, thousands of cache reads. That is a huge performance improvement. Database load decreases. Response speed increases. And users get a much better experience. This is why caching is so powerful. But there is a problem now. Another important question appears. What happens when the data changes? Suppose the user updates their bio or changes their profile picture. The database now contains new information, but Redis may still contain old information. That means users could see outdated data, and that is a problem. So how do we fix it? Cache invalidation. Whenever the data changes, the application first updates the database, then it removes the old cache entry from Redis. This process is called cache invalidation. Now Redis no longer has the old data. The next request becomes a cache miss. The backend fetches fresh data from the database, stores the fresh version in Redis, and everything becomes correct again. Simple, but extremely important. Let's quickly recap. A request arrives, the backend checks Redis. If the data exists, cache hit, return immediately. If the data doesn't exist, cache miss. Go to the database, get the data, store a copy in Redis, return the response. And if the data changes later, invalidate the cache, so future requests receive fresh information. That is the complete cache aside pattern. Simple, powerful, and used by countless applications every day. Outro. Today we learned how real applications use Redis to reduce database load. We learned cache hits, cache misses, why Redis sits between the application and the database, and how cache aside actually works behind the scenes. But now another interesting question appears. What happens when millions of users request the same data at exactly the same moment? And the cache suddenly expires? That leads us directly into our next topic, cache stampede. And trust me, things get very interesting from there. Thank you for watching. See you in the next video.